Broadcast is now starting. All attendees are in listen-only mode.
Welcome everyone to today's webcast, Making JD Edwards Elastic with Containers and Autoscaling, using Docker containers to improve the efficiency and scalability of your JD Edwards system. This is GSI Safe Harbor. Please take a moment to review it. My name is John Bassett. I'm an executive with GSI and also our Chief Technology Officer and our Security Officer. I'm in charge of our cloud practice, our cyber and JD security practice, database practice, and internal IT. So first question is, what is containerization? Before we actually give a definition of containerization, let's talk a little bit about the history of computing and compute power. Prior to 2010, you're in the physical hardware from when it comes to servers. Some of the larger machines like IBM had LPARs, and there's been some, other expensive virtualization equipment. But around this time, 2010, VMware came out and Hyper-V and other competing offering a hypervisor to sit on top of your equipment and allow you to share resources. That allowed you to create multiple servers off of the same physical equipment and other sophisticated techniques like moving servers from one box to another across data centers, etc. Around 2015, the cloud services started to take advantage of some of the hypervisor technology. Although AWS had been around a lot longer, it really was kind of a niche market. But when Microsoft entered the market with Azure, it started to take off. Other players started coming in. You also had, prior to that, you had some hosting providers that had taken advantage of the virtualization, the sophisticated equipment of Cisco, UCS for high-end processing. But there's still a few issues with that, and around 2013, a little bit before that time period, Docker had made his debut as a containerization offering, but it took a number of years for that to be adopted, for people to understand how it could benefit them, why they would use it over virtualization. And it has taken quite a bit more time. Around 2016, 17, it started taking off a little more. Around 2020 is when Oracle started working to make JD Edwards work in containers. Allows for a smaller compute footprint, which is ideal for cloud type situation. And the idea is in the future is to reduce support costs on projects, reduce maintenance, and also allow you to use the compute power as you need it, not to pay for maximum resources at all times. So who would benefit from containers? Well, basically all companies can benefit from containers. Small companies can see some of the safe healing capability, portability, where they might have been a little lax on disaster recovery. Now it becomes a little bit easier. Rolling back from failures is critical. Medium-sized companies, of course, can take advantage of some scalability, real-time deployments of changes, reduce system administration. And the one company that can benefit the most is the very large company. If you're currently spending a lot of money on support services, a lot of money on equipment, near zero downtime, performance normalization, even based on increased workloads or variable workloads. And another benefit is multi-cloud options. One of the things you can do with containerizations is build your containers, share up to a storage location like GitHub or some other place that you might have or maybe using, and then download the container into the different platform. Azure supports containerization, as does the Oracle Cloud, as does AWS. So many different cloud platforms will accept containers, and therefore you could scale into other platforms, compare one against the other. So on to our definition of containers, and the best way to explain containerization is to compare it to virtual machines. We're 10 plus years into VMware, and everybody sees the benefits there. So let's compare it. On the left-hand side, we have a virtual machine where we have the underlying infrastructure. Well, we have the same thing in containers. Then we have our host operating system, whether it be Windows or Linux or form of Unix as the host operating system. Now here's where things change. In a virtual machine, you now have a hypervisor, whereas in containers, you have something like the Docker engine. And Docker is the default standard for the engine right now. The layers above it can be different. Like you could use Docker Swarm to manage the multiple containers, or you can use Kubernetes in many cases. There are some support issues though with Kubernetes, and you may need to check your minimum technical requirements to see if you can even use it at this point. So on the left, you have the hypervisor, and then basically each virtual machine guest with its own guest operating system and its application. Perhaps you have a deployment server, and you have an enterprise server. You have web servers, and database servers. Over on the right, in the container side of things, you don't have another guest operating system. So if you're using things like Windows and paying for a Windows license, you could potentially, get some savings in operating system licenses because you're really only licensing the main host. But then instead of you have your different applications running there as containers, maybe Java layer, a WebLogic layer, the JDE layer, it's etc. And the various components, application A, B, and C above would be application A, B, and C in the host containerization. So, now we'll talk about some of the advantage of doing it this way. I mean, there's it may not initially be clear to you what the advantages other than maybe saving some money on an operating system or two. So the first thing is that you're going to see is compute savings. Current systems in the VM world or physical world are built out to handle peak loads. So if you have a system that it needs 500 users, but on average you're only using 100, you're paying 5 times the amount of money for your peak load at all times, evenings, weekends, holidays, etc. Expanding a system to handle the growth is costly. Projects to add additional servers, you got a budget, and you've got to expense things. So with containerization, you basically have automated compute density scaling versus having to design your system for max capacity. Now, it's probably ideal to design your system for a minimal system or an average system. And that's what we've done in this example. We have intelligent infrastructure. We have node 1 and node 2, but node 3 and node 4 stay silent. This is really useful if you're paying for cloud computing, is you don't pay for nodes that aren't running. You pay for storage, but you don't pay for the memory and the CPU for something that isn't running. So when you can dynamically or manually bring up the additional nodes when you need it. So if your average workload is 100, great. Nodes 1 and node 2 are handling it with your batch server, etc. But as you get to peak seasons, maybe you have a year-end closing where you've got 500 users on the system. Well, scale up at that point in time, and you can work with the either Swarm or Kubernetes. If you're on a much later tools release, you have to again check the MTRs for Kubernetes, and you can run scripts that can check for CPU, RAM type situations, and that can automatically spin it up, or you can manually spin it up as well if you know it's coming and you just want to be ready. Some other savings, non-production, offline savings. You can schedule offline hours for non-essential system and infrastructure for additional savings. Um, you know, the non-production systems versus always on. You can look at an offline as well. Schedule things for 12 by 5, save 57%. Do 9 to 5 for even greater. And so the idea there is if you don't need the non-production systems, spin them down, schedule them to come back up. Workstation optimization, this is a little bit tricky right now. So we've been working on trying to figure out how to scale workstations, deploy to one workstation and scale to another, lower support costs, and definitely making it easier. And this is a problem a lot of JD Edwards people complain about, is that does take quite a bit of time to keep a large development environment up and running. If you have 10 workstations, every time you take a package, it's each workstation has to take the package, and there may be differences amongst them. But if you containerize it and just push the containers to the multiple workstations, it would save you some time, effort, and support. the Windows licenses may or may not be savable in that case. We've been looking into that, but it doesn't look. We were thinking you could share the operating system, but it looks like you may have some issues there. So reduced downtime is another advantage of containers. I'd say it's consistent with virtualization, but tends to be a little more robust. Um, Production, with your offline maintenance and patching, you've got to trade off for stability and updates. Another good thing is you can reboot. If you have memory leak issues, which hopefully you don't by now, um, you've got your tools release up to date, you've got ESUs, and you've done the performance and memory issues. Hopefully you don't have that problem, but if you do, it's a little bit easier and it's faster to boot a container than it is a virtual machine because the operating system doesn't have to load. So if you have like memory leaks, you can um, you you can just bring down a VM and bring up another one. Package build times can be saved along with package deploys. If you change your complete model, you can build and deploy to an offline container, and then just push out the new container. And you can even drain stop it if you need to bring up new ones as well. You can also patch at the various layers. You can patch the OS, you can patch the Java runtime environment, the web application, independently, and so you can take in building a container, you could update the WebLogic layer, let's say, and push just that out over to the containers after you've done your testing and make sure it's works without bringing down a whole server, like you have to do today if you want to take an update. Most people are just building an offline server and then putting the new one in place. So this is kind of how containers work, and even though we call it advantages, this is more an idea of how it works. Is you basically create an image library of containers, an enterprise server, a web, and you can create versions of them. You could put in a V1, V2, or you could put in a date that you created it. And you've got a utility node that allows you to create the updated different types of servers. Again, we mentioned that you drain stop when moving from the image library into the nodes. You could do dynamic or manual rollbacks if you need to, and it makes it easy to update the operating system and to do various patching. So here's some other advantages in the self-healing technology. If for some reason uh, a node starts to peak at 100%, you can you can flag it, or it can automatically be flagged based on conditions as unhealthy, and we could spin it down automatically, bring up other containers. There's dynamic load balancing with Docker Swarm, that you can schedule based on CPU memory loading. In addition, you do have the health monitoring that I mentioned before, and you have to basically decide what it is. CPU and RAM are obvious, but that may not help you with your JD Edwards. It may be the CPU and RAM meet the criteria, you're over 90%, maybe that is acceptable, maybe it's not, you have to decide. But you could also add like URL checks to see if you can sign in and to determine if the particular node is acceptable. In GSI, we have our own Genius AI health monitoring that we've integrated into JD Edwards, including the Docker swarms to help with notifications, and inform people that things might not be okay, or may need some attention or looking into. Now, just some additional features we wanted to talk about, and that is this transportable DR. We mentioned that the different servers in the previous slide, you can have image libraries. Well, you can upload those image libraries to other locations. Like you could put it up to GitHub, And then if you're running this, let's say you're running it on premise, but you want to also have as a backup running things in Azure because you don't want to have the additional equipment on site. Again, upload it to GitHub, and then you could have GitHub download the container from GitHub and run Docker from Azure or AWS or Oracle, and give you basically some offline DR savings if you need to quickly get your system up and running in another cloud. It can make migrations a lot easier if for some reason you find that Azure has become too expensive and you want to move to OCI. It's very easy to shift between cloud providers. You can just say, well, you know what, we're tired of paying for Microsoft, and we're on an Oracle database. We want to go to OCI. We think we'll be better served there. Well, you can just shift between cloud providers by downloading your images and start running days instead of months on your migration. Instant lab environment. You can spin up a lab in a new instance in the same cloud or into a new cloud and basically do maybe some testing. GSI has Genesis load testing, and if you want to do like a code current project, you could just run it on the lab environment and then basically snap images of it, and if everything's good, move it into place into production. And again, Genesis is a stress testing, load testing solution. So just some notes for you on containerization. You do need to be cognizant of your tools release. Server Manager really needs to be on tools 9243. And it's kind of a requirement for the clones, because each one of the nodes, let's say you have an enterprise server, you call it JDE ent. Well, the node would be like a .1, a .2, .3 for the machine names, and now although the underlying code hides it, it would still be called JDE ent. The last node up is the one that Server Manager will manage prior to this tool's release, but they fixed it. Oracle fixed it and patched it, and each one of the nodes can be managed inside of the .1, 2, 3s, et cetera, can be managed in it. Another issue is that because of the different underlying names behind the scenes, there's a get host by name function in JD Edwards. If you submit UBE jobs, the UBE job is embedded with the machine name, and it can be a little bit of a problem unless you've got a virtual IP and common storage can be a little bit of a challenge. But starting, so basically what we're saying is for your batch server, we're not exactly recommending containers just yet. Somewhere this quarter, late fall 2020, the tools release support for batch server cloning is in place via virtual queues. So once you got the virtual queues sometime in early 2021, if you've got a tools release planned, you'll also be able to create containers for batch servers as well. In addition, Oracle is not exactly recommending that you that you virtualize, excuse me, not virtualize, but containerize the database. I'll talk about that in a moment. I'm going to talk about a reference architecture that GSI is building out in a minute. So in summary, this containerization is a technology future. It's revolutionizing technology. It's a new way to support your JD Edwards system. And it's a new way you can support all of your systems. You'll have people that don't need to spend as much time supporting a system, and they'll spend a little more time building new containers with new changes that don't affect production. So making your downtime near zero, maybe reduced overhead, certainly lower compute costs, perhaps less licensing costs. You got auto-scaling infrastructure, et cetera, and some self-healing capabilities with containers that will restart if there's issues. So, oops. I had a slide here. I wanted to show you a reference architecture. GSI has created a reference architecture that where we have a container set up. And the one thing that I really wanted to talk about on the reference architecture is that Oracle really does not recommend containerizing a database in the sense that it can, you can scale up based on load, at least for JD Edwards. The nice thing is that these containers are, many of the containers Oracle provides GitHub source code for it. So you can get like a 19C database, 19.3 database container and download it. Well, if .4 comes out, you can just, get the next one and try it out. But for JD Edwards, if you want some of the advantages of container, that's great. Put it in a container, it will run, but don't scale it just yet. There are other scaling capabilities in the database, rack, et cetera, like that, and failover through DataGuard is still Oracle's recommended solution. So, but if you want to take advantage of the multi-cloud capability, then go ahead and put it in a container, upload it to GitHub so that you could use it for multi-container and maybe for DR, but the recommendation is still not to do that. So GSI is offering an in-focus special price. Sorry, the price is $9.95, not $49.95. Sorry about that. It's valid until November 15th. And what you could do is you review the MTRs and the JD Edwards architecture for you. We'll look to see if you can take containerization, whether Kubernetes is an option for you, whether you need to take tools releases or apply ESUs, and document the findings and recommendations in order to move forward with containerization. So basically, we'll try to create a roadmap for you. And again, the price is not $49.95, it's $9.95. So with that, that's the end of our session. If you have any questions, feel free to email them to me, john.bassett, BASSETT, @getgsi.com. Thank you.